Okay, here's my first homework video I've ever created. So we're going to review the unit circle. Here's your key for your homework. I'm going to zoom in a little bit. That way we can see each problem. So the goal for you guys is to be able to do this process that I'm about to do to figure out the cosine of 3 pi over 4 in your head. Okay? And I find that it's helpful to, and I talked about this in the lesson, recall SOHCAHTOA, and remember triangles, not remember coordinates. So 3 pi over 4. First thing I'm going to do is find the location of an angle. Well, I know pi is here. I know going clockwise would be subtracting an angle. Going counterclockwise would be adding. So if I start at pi, knowing that that's the same as 4 pi over 4, I could subtract the pi over 4, and I'd be in the third quadrant. This would be the location of 3 pi over 4. Okay, and then I go ahead and understand that this is a circle that's going around. So this is why I stopped my angle, because I have a circle. This hypotenuse is 1 for this right triangle that I'm creating, which is our 45, 45, 90 triangle. Why is it 45 degrees? The reference angle to the x-axis, because we have a pi over 4, and all pi over 4s would be a 45 degrees. So in my special 45, 45, 90 triangle, I have side lengths of root 2 over 2. I consider this negative because I'm going to the left on the x-axis. This is positive because I'm going up. So cosine in the SOHCAHTOA, the ka is adjacent over hypotenuse. Adjacent would be the horizontal if we're always talking about a reference angle between our angle and the x-axis. Adjacent is always the horizontal distance. The horizontal distance of my triangle that I create is this negative root 2 over 2. Okay, and that's my thought process in my head. Find the angle, create the triangle, cosine, adjacent, always going to be horizontal. Here's sine, 5 pi over 3. I know where 6 pi over 3 is. It's here at 2 pi. So I'm thinking, okay, this is 2 pi. That's the same as 6 pi over 3. Again, I'm going to subtract. Again, if we go counterclockwise, that'll be adding. If we go clockwise, that'll be subtracting. So take a pi over 3 away, and that puts me in this fourth quadrant at 5 pi over 3. A pi over 3 is a 60-degree reference angle. So I'm creating this tall 30, 60, 90 triangle, where in a 30, 60, 90 triangle, I have a shorter side and a longer side. Well, if it's a tall 30, 60, 90 triangle, the shorter side, the 1/2, is going to be the adjacent side, or the horizontal side. The longer side is the vertical side. That's the root 3 over 2. However, since I'm going down on the y-axis, this would be a negative root 3 over 2. This 1/2 is a positive. Sine in the SOHCAHTOA, sine is opposite. It's always going to be the vertical. So cosine is always the horizontal. Sine is always the vertical. So sine being the vertical, opposite root 3 over 2, negative. Okay, that's the vertical side length. That's opposite. Remember, the hypotenuse is always 1. So opposite over hypotenuse, if you want to think of so. But whenever we're doing this, understand hypotenuse is always 1. Okay, tangent 3 pi over 4. I already did a 3 pi over 4 over here. Tangent is sine over cosine, or opposite over adjacent, or vertical divided by horizontal. Vertical divided by horizontal. For tangent for a pi over 4, it's going to be root 2 over 2 over negative root 2 over 2. That's going to be just 1, but negative 1 since it's a positive divided by a negative. Sine of 4 pi over 3. Let's find 4 pi over 3. Here's 3 pi over 3. It's the same as pi. Add now. Adding is going counterclockwise. So starting at 3 pi over 3, adding, going to 4 pi over 3 would be here. I create my 30, 60, 90 triangle, knowing that it is the taller 30, 60, 90 triangle. The adjacent side would be shorter. The longer side, the root 3 over 2. Both would be negative since I'm going left and down. Sine of 4 pi over 3, opposite side, vertical distance, negative root 3 over 2. Cosecant, first thing we got to remember is that cosecant is the reciprocal of sine. So I'm going to find the sine of 7 pi over 4 and then just flip it We'll put it under 1. I got to find 7 pi over 4. I know where 8 pi over 4 is. 8 pi over 4 is right here. Subtract a pi over 4. Again, adding, subtracting. So going around clockwise is subtracting. Puts me in the 4th quadrant. We have a triangle with side lengths of root 2 over 2, since it's the 45, 45, 90 triangle. And we would have a negative vertical distance, since I'm going down with my triangle on the xy axis. Sine opposite over hypotenuse. The vertical side length is negative root 2 over 2. So I'd have 1 over negative root 2 over 2. This is the same as 2 over negative root 2. In this class, it is not a requirement to rationalize. You can leave your answer as negative 2 over root 2. So sometimes on multiple choice problems, you'll see this being simplified. We'll talk more about simplification throughout the course of the year, but the easy way to talk about simplification is for AP Calculus. Simplification is not required for free response. However, it might be required to see the correct answer on a multiple choice problem. So you're not required to simplify this if this was just a regular problem on like a quiz, but you may be forced to know how to rationalize this in case you don't see this answer on a multiple choice problem, and you need to realize that this is the same as 2 root 2 over 2, which is the same as negative root 2. Okay, E2's will cancel, we have just multiplication. Cotangent pi over 4, this is easy. Tangent and cotangent are reciprocal, so if I just find the tangent of pi over 4, just flip it or take it 1 over that fraction, pi over 4. Cotangent you can even consider as being the adjacent over opposite instead of opposite over adjacent. Pi over 4, we have our 45, 45, 90 triangle. So adjacent over opposite is going to give us 1, or opposite over adjacent will give us 1. This will be 1 over 1. This is good. All right, pi over 6. Finally, we have a pi over 6, which creates a 30-degree reference angle with the x-axis. Here's 0. Add a pi over 6. We will be going counterclockwise. This creates our shorter 30, 60, 90 triangle. And in our shorter 30, 60, 90 triangle, the vertical side is the shorter distance. The horizontal side is the longer distance. Cosine being adjacent or the horizontal distance is root 3 over 2. Now, I could be doing this on my head. I'm kind of showing you the thought process I have in my head so that hopefully you can do the same, so that we don't have to be spending so much time on these. Like, I can easily go sine of pi over 2 is 1, or the cosine of pi over 6 is root 3 over 2, after just thinking about it for a little bit. But I'm showing you this stuff is my mental process. Why is the sine of pi over 2 1? So this is when we start talking about the extremes. So when we're on the x-axis or on the y-axis. Pi over 2 is halfway from 0 to pi. So halfway from 0 to pi would be right here. It's a 90-degree angle. And why is sine 1? Well, again, sine is always the vertical distance. Okay? I know you're thinking opposite over hypotenuse, but like, we don't have a triangle here. I just have a straight line. But it's okay. We can consider us having a triangle with the adjacent side or the horizontal distance being 0, whereas the vertical side, which is the opposite side, which is the vertical distance, being 1. The hypotenuse stays 1, so we don't really have to worry about it. Just sine, opposite, vertical distance, I'm going up 1 to get to this location on my unit circle. Pretend like we have a unit circle there. And I will travel up 1 to get to pi over 2. I will not go to the right or to the left at all if you consider starting at the origin. Okay, the horizontal distance is 0, the vertical distance is 1. That's why the sine of pi over 2 is 1. That's why the cosine of 0, if I ask you what is the cosine of 0, Well, here is the location of the angle measurement 0. I will travel to the right 1, but I will not go up or down at all. So since I don't go up or down at all, but I do travel to the right 1, the cosine of 0 is 1. All right, 3 pi over 2. Another extreme, 3 pi over 2 is down here. Tangent, opposite over adjacent, vertical divided by horizontal. Vertical distance, I'm going down 1. Horizontal distance, I'm not traveling to the left or to the right at all. So vertical, horizontal, that would be tangent, opposite over adjacent. Negative 1 over 0, that is undefined. You are not allowed to divide by 0. So there is no tangent of 3 pi over 2. It does not exist. Cosecant of pi over 3. Cosecant is the reciprocal of sine. So we'll start with the sine of pi over 3. And we will flip it or put it underneath 1. So pi over 3 creates our 60-degree reference angle. It'll be in the first quadrant. It's our tall 30, 60, 90 triangle, which means this is our longer side, the vertical side. This is our shorter side, the horizontal side. Sine of pi over 3, root 3 over 2. That is placed under 1, sine being the opposite or the vertical side distance. So that's placed under 1. So what do I do here? I can either 1 divided by root 3 over 2, that's the same as 1 times 2 over root 3. Remember, when you're dividing fractions, it's the same as multiplying by the reciprocal. We can multiply straight across to get 2 over root 3. This is fine. You may leave your answer like this on a quiz. However, you need to be prepared to rationalize for like a multiple choice problem if you don't see this answer on a test. So for a quiz, this is fine to leave it 2 over root 3, but be prepared to simplify and rationalize. I don't want to call this simplifying. I don't think this is simpler than this. This is just a different way to look at 2 over root 3. So don't call it simplify, call it rationalize. All right, popping over to 11. Sine of 7 pi over 6. Okay, I know where 6 pi over 6 is. It's the same as pi. So here's pi, here's 6 pi over 6. So I'm thinking about that first. 6 pi over 6 is just another way to write pi. If I add a pi over 6, that puts me in the third quadrant. Pi over 6 gives me a reference angle of 30 degrees. That's a short 30, 60, 90 triangle. So here's pi, 6 pi over 6. Add a pi over 6 puts me there. Remember, adding, subtracting. Sine is our vertical distance. For our shorter 30, 60, 90, the vertical distance is going to be the shorter side length. The horizontal distance will be the longer side length. I'm going down, so my vertical side distance is negative. I'm going to the left. My horizontal side distance is negative. So sine of 7 pi over 6 being the opposite, or the vertical, is negative a half. Secant, reciprocal of cosine. Let's find the cosine of pi over 6. Pi over 6, again, 30-degree reference angle, short 30, 60, 90 triangle. Short 30, 60, 90 triangle. Vertical is the shorter side. Horizontal is the longer. Cosine being the horizontal or the adjacent. That's the longer side. Cosine adjacent over hypotenuse. Adjacent over hypotenuse. Horizontal side length divided by 1, or just the horizontal side length. We can write it like this. This is fine. We can write it like this. This is good. We can rationalize as well, which we just did in the previous problem. Secant, reciprocal of cosine. Let's find the cosine of 7 pi over 4. We have to locate 7 pi over 4. Where is 7 pi over 4? Well, I know where 8 pi over 4 is. It's over here at 2 pi. Remember, this is 0. This is pi. Keep going around. This would be 2 pi. Well, I can write 2 pi as 8 pi over 4. I can write it as 6 pi over 3. I can write it as 12 pi over 6. This is how we find those angles. 7 pi over 4 would place me right here, 1 pi over 4 less than 8 pi over 4. So subtract the pi over 4, go in a clockwise manner. Creating our 45, 45, 90 triangle. side lengths root 2 over 2 and root 2 over 2. This would be negative because I'm going down. This is positive. The cosine would be our adjacent side length, our horizontal side length, our positive root 2 over 2, which goes in the denominator. So I have 1 over root 2 over 2, which is the same as 2 over root 2. Which is the same as 2 root 2 over 2, which is the same as root 2. And a reminder, you can multiply the top and bottom by root 2 to get this. All right, I'm just going to breeze through the rest of them. I feel like I've shown enough examples. Maybe I'll do the cosine of pi, but here's what I'm doing. In my head, sine of 2 pi over 3. Okay, 3 pi over 3, subtract the pi over 3. That's going to be put me right here. 2 pi over 3 is our taller. Sine would be our vertical side length. Vertical side length, since I'm going up, is the longer side of my 30, 60, 90 root 3 over 2. Tangent of 5 pi over 6. Okay, 5 pi over 6 is going to be right here because this is 6 pi over 6. Subtract the pi over 6. I put 5 pi over 6. Tangent is opposite over adjacent, vertical over horizontal. The vertical is the smaller side length. The horizontal would be the longer side length. I am going up and to the left to get here. So I have 1/2 divided by negative root 3 over 2. You can leave it like that, but you probably need to understand how to simplify it. Fractions multiplied by the reciprocal of the denominator. Boom, you have 2 over 2 root 3 being negative. The 2's cancel. I have 1 over negative root 3. That's fine. You can leave it like that. But we need to know how to rationalize, multiply the top and bottom by root 3, and you get negative root 3 over 3. Sine of pi over 3, pi over 3, right here, so 60 degree, taller 30, 60, 90, sine the longer side is the vertical side, so sine opposite, that's the longer side, that's the root 3 over 2. Secant of 5 pi over 3, well, secant's a reciprocal of cosine, so let's find the cosine of 5 pi over 3. 5 pi over 3 down here, this is 6 pi over 3, take 1 away. Cosine would be the shorter side length, cosine is going to be 1/2. So I'll have 1 over 1/2 because this is the cosine of 5 pi over 3. So I have 1 over 1/2. I'm going to the right and then down. If it was the sine, it would be negative root 3 over 2. But anyways, the reciprocal of 1/2 is just 2, or 1 over 1/2 is just 2. Cosine of pi, pi is over here. If you think about on a unit circle, to get over here, we have a horizontal distance of -1 since I'm going to the left. I do not have any vertical distance. I'm not going up or down. Cosine being the adjacent or the horizontal distance. The horizontal distance to get over there is -1. Cotangent, adjacent over hypotenuse, or horizontal divided by vertical. 2 pi is the same location as 0. So horizontal distance would be 1. Vertical distance is 0. I'm not going up or down at all, starting from the origin, getting to this location on my unit circle. So horizontal 1, vertical 0, undefined. All right, tangent is opposite over adjacent. So that would be vertical over horizontal, cotangent, flip it. Secant, reciprocal of cosine. Cosine of pi. We already did. It's -1. 1 over -1. -1. Sweet. All right, so hopefully we breezed through that. If we are good, if we are not strong at this, this needs to all be able to be done by memory without referencing any other charts or manipulatives we created. We need to be able to create these triangles and use our brain.